In this example, we'll be calculating the slope of tangent lines using limits. In our first example, we'll set up a theoretical graph of some function f of x with the x-axis and the y-axis. Now in this example, we want to find the slope of the tangent line at this point right here. We'll call that point x sub naught, and its corresponding y value will be f of x naught. Now we can just draw the tangent line. Remember, the definition of a tangent line is a line that passes a circle at only one point, or passes another line at only one point, or a curve. So this line right here, straight line, passes this curve here at only that one point. And we want to calculate the slope of this tangent line. Now, we can approximate the slope of a tangent line if we redraw this. As two different points, and if we find the slope of the line between those points, that line there is close to this line here, so we'll use it as an approximation. And we'll find the slope, if remember the slope, m, is equal to the rise over the run, or the change in the y, or change in height. And so since we're dealing with 2 points with values of x naught and values of x in corresponding y values of f of x naught and f of x, and their corresponding change in y and change in x will be f of x minus f of x naught over x minus x naught. Now this can be used as a crude approximation for the slope of the tangent line. But we want to be a little more precise. We want to be very precise. So what we'll do is, if we keep on moving, redraw the graph, and keep on moving those 2 points closer and closer to each other, with our first point here of x naught, if we have another point here, which is a little bit closer, then we can get a little better approximation of the tangent line. And if we move the dot even closer to our x naught, we can get an even better approximation of the tangent line. And if we move that dot right on top of our x naught, we'll get exactly our tangent line. Now the only problem with making x equal to x naught is if x is equal to x naught, then the denominator of this here is equal to 0. We can't have that. So what we're going to say is we're going to make a limit as this approaches 0. So we'll rewrite this as the slope is equal to the limit as x approaches x naught. So as x right here, as it approaches, goes that way, closer and closer to x naught, but doesn't quite touch. Remember, if it touches, we get 0, of f of x minus f of x naught over x naught. And if we calculate this limit here, this will give us the slope of any tangent line. What we'll be doing now is simplifying the equation that we just calculated into making it easier for our later calculations. So if we know that m is equal to the limit as x approaches x naught of f of x minus f of x naught all over x minus x naught. And what we can say is we're going to create a variable called h and define it as x minus x naught. And we're going to replace anywhere where it says x with h plus x naught. So rewriting m, we can write m is equal to the limit. We're not quite sure what that's going to be yet. We can calculate it in just a second. Of f of x naught plus h minus f of x naught all over h. And we want to find when this goes to 0 down there, so it's when h approaches 0. So the limit as h approaches 0 of all this is our new function that defines m. Now we'll make our calculations a little bit. The next example, we'll actually be calculating the slope of an equation at a certain point. We'll use f of x is equal to x squared plus 2 as our equation. We'll have our point x naught equal to 2. So rewriting this equation right here, we have m is equal to the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Inserting the equation of f of x in for f of x, we get the limit as h approaches 0 of 2 plus h squared plus 2 minus 2 squared plus 2 all over h. If we can continue to work our way through this, we get the limit as h approaches 0. Foiling this right here, we get h squared plus 4h plus 4 plus 2 from that right there minus 2 squared is 4. Remember, I have to be minus. And let's also remember to distribute that minus sign into over here, minus 2. Simplifying this, the plus 4 and minus 4 cancels out, and the plus 2 and minus 2 cancels out. So all that we're left with is h squared plus 4h over h. So we can now factor an h out of the top right here and get the limit as h approaches 0 of h times the quantity of h plus 4 all over h. The h over the h's cancel out, and we're left with the limit as h approaches 0 of h plus 4, or solving for the limit, we get 0 plus 4 is equal to 4. Next, what we'll be doing is we'll be calculating the slope at every possible point of x naught, or at any point of x naught. So we have the limit, the slope is equal to the limit as h approaches 0 of f of x naught plus h minus f of x naught all over h. Putting in the equation, we get the limit as h approaches 0 of x naught plus h squared plus 2 minus x naught squared plus 2 all over h. Foiling out the squared, we get the limit as h approaches 0 of h squared plus 2h times x naught plus x naught squared plus 2 from there minus x naught squared. Remember, this minus sign we have to distribute into here and also distribute into minus 2 all over h. We can now cancel out the plus 2, and the minus 2, and the plus x squared and the minus x squared. So all that we're left with is the limit as h approaches 0 of, remember again, we can factor out this top h here and get h, so the limit as x approaches 0 of h times the quantity of h plus 2x naught all over h. The h over the h's can cancel out, so we're left with the limit as h approaches 0 of h plus 2x naught. Solving the limit, we get the 0 plus 2x naught, or just simply 2x naught. Now to kind of prove to ourselves that this answer here is the same as this answer up here, in the last problem we said we want to know the slope at x naught is equal to 2. So m of 2 is equal to 2 times 2 is equal to 4, which is the same answer we got right back up there. The last thing we'll be doing in this review is to be actually solving for the equation of the tangent line. So restating our equation, f of x is equal to x squared plus 2. We want to find the equation of the tangent line at x naught is equal to 2. Now we've already solved and found that the slope of the tangent line is equal to 4. So with the slope of the tangent line equal to 4, we know that the slope of an equation is m is equal to the change in y over the change in x, or rewritten as x or y minus y naught all over x minus x naught. Now to find y naught, it's equal to f of x naught, or 2 squared plus 2 is equal to 6. So we put in y minus 6 all over x minus 2. Now when we find the equation of a line, we normally have the equation of line in the terms of y is equal to mx plus b, where m and b are constants. So we'll change this here into this form. So first we'll multiply over the denominator, so we get m is x minus 2 is equal to y minus 6. Remembering that m is equal to 4, we can distribute it in, so we get 4x minus 8 is equal to y minus 6. Moving the 6 over the other side, we get 4x minus 2 is equal to y, or the equation of the tangent line is equal to y is equal to 4x minus 2. That's the final equation of our tangent line at the point x equals 2. I hope this review helped you understand the slope of tangent lines and finding the equation of tangent lines, and that you come back to the next one. Thank you.